Okay, everybody. Thank you all for attending here today. And so I have Steve Fambro here on my left, and on my right, I've got Daniel Barrow. And what we're going to do is talk a little bit today about, well, first off, I'm going to have them introduce their businesses because you may not be 100% familiar with either company. These companies are very innovative. And in the case of Daniel's company, a lot of their techniques and technologies have been developed by themselves. And in Aptera, of course, Aptera is radically different. Doesn't have as many wheels as the rest of the car companies, and it basically runs for free. So, but before I get into any of the questions, what I'd like to do is start off by letting them explain a little bit about what a teaser I just gave out. So, Daniel, can you give us a little bit of a background?
Of course. So Reed is a technology company. We're a technology company in the automotive world. And what we do is we basically build software-defined vehicles or by-wire vehicles. We have a very advanced tech that allows us to put by-wire technology, which means we steer, brake, and drive fully by wire in any kind of vehicle. We call it the Reed-Cornered. What we're basically able to do is with an array of ECUs, computers, and software, we're able to control the entire vehicle in a much better, safer, and far better operational-wise for the users. Our main customers today are the likes of Penske, U-Haul, UPS, and even Airbus, with whom we run an autonomous program. We're starting production now. We've been around for about 11 years now, so we're probably one of the oldest of the new ones. That's not an oxymoron, but yeah, that's about us.
Let's talk a little bit about Aptera.
Sure, thanks, Dan. My name is Steve Fambro. As CEO, co-CEO, co-founder of Aptera Motors. We've been in business since about 2019. We have a simple mission at Aptera. That's to make every journey powered by the sun. We do that through a vehicle that gets 400 miles range. We've designed, you might think of it as a range extended electric vehicle. But instead of a gasoline engine, it has solar cells, solar panels. Solar panels that we design, that we make. That's a big part of our intellectual property portfolio, how we bend them and curve them in 3 dimensions and make them automotive grade. Aptera uses extreme efficiency both with low drag aerodynamics, lightweight composites, and of course our solar technology to make probably the most efficient vehicle in the world. It uses about 100 watt-hours per mile. It's 400 miles range on a tiny 40 kilowatt-hour pack. We've got about 50,000 pre-orders, about 2-3 years of production pre-sold. So we've got a lot of work to do to build it, and it's in production. We're almost there.
Okay, it's got one major feature. How many wheels is your car?
3.
3. So for those of you who say, oh, 3 wheels, oh, that's going to flip over. How many people here have ever seen me drive anything on Monroe Live YouTube? Yeah. Did you see me hold back? No. Okay, so at the end of the day, they gave me a 3-wheel vehicle to try out. And I did my utmost. And they said, oh, yeah, go ahead, see if you can flip it over. And I did everything I could, and I couldn't even lift a wheel. So at the end of the day, before anything about torque steer and flipping the car over, anything, I can tell you for sure that is not going to happen. No way. If I can't flip it over, it can't be flipped. So there we go. So now what I'd like to do is jump right into it. And you're not in production yet. Where exactly is Aptera right now with, getting to production? When do you think it might be happening and things like that?
Right now, we've begun building our very first, what we call PI vehicles, a production intent. It's a group of about 16 vehicles for validation. Most of it is off production tooling, but not all of it. But the big pieces, the important pieces are, especially the body. So what you people call the body in white, that's in Detroit. What the industry calls body in white, that we call the body in carbon or pink. So that's off of tooled parts. All of our, our software, hardware, vertically integrated. We have our own software team writing embedded software. So just about everything but the powertrain is in-house. All of that has been released into the first production intent, or first group of 60 vehicles. I just got a picture last night. They put the wheels on it. I think they're going to drive it maybe before I get back, just to spite me, instead of waiting till Thursday morning. But that's where we are. We started that first process with first 16. Now, production is not going to occur until late 2025, maybe 26. And that's dependent upon funding. It's about 9 months after we close this round of funding when we can start shipping vehicles. But it's very exciting to see the first production intent be assembled. And everything just, it looks and fits exactly, like it does in the CAD, which is great.
Excellent. So you mentioned that that you have a body in carbon. Can you elaborate on that so people can kind of grasp the concept of what you've got versus what a normal stamped vehicle might look like?
Sure. Well, when we first started the company, my co-founder has a lot of experience building boats, had a boat company making wakeboard boats. They built a couple thousand a year. And we thought we could use the same, resin fusion composite methods. So when we started the company, it took reservations. We thought we'd be building a couple thousand vehicles a year. We got a couple thousand reservations in the first few weeks. So we said we need a different way to make this body, hand laid, fiberglass. It just wouldn't work. We can't scale for production. Even with lots of people, we toured composite plants in Mexico and other places, and it just wasn't scalable in this way. So our VP of engineering at the time found, sitting right there, found a company in Italy, CPC, that helped us develop this ink with a radical new process where the carbon sheet mold compound is actually mixed on site. So it's not refrigerated and shipped in a cold chain like typical SMC materials. And then it's pressed into a part in about 5 minutes. So we're pressing out tool parts about every 5 minutes that are ready for wrap, or if we wanted to paint, we'll be ready for paint. We don't paint. We don't have a paint booth. We don't have that cost, that burden. But the parts come out of the mold ready just to be deflashed and then used. And each one of them are perfect because of the tooling. The tooling was the single largest cost of the program so far. These massive, 8,000 kilogram steel blocks made into these tools. But instead of a progressive die aluminum or steel part where you might have to make several different presses because of the shape, these parts come out in one press. So every 5 or 6 minute part comes out. We're able to do 40 vehicles a day with the tools that we have. We just need to get to that step in terms of the assembly process.
So one of the things that I'm not sure how many stampers we've got in the audience, but prior to becoming an engineer, I was a tool maker. And making stamped parts consistent is extremely difficult. Steel warps, especially when you weld it. And then bits and pieces come in slightly different to each other. And in a lot of cases, you're kind of bending the part into shape when you have your welding fixtures. And when Steve was talking about a perfect vehicle or a perfect part, carbon fiber is a stone. It has no warp. It doesn't distort with heat or cold. And it gives you the opportunity to build a perfect car every time. What does that mean? Well, on the assembly line, you have some extra tools usually that people don't really see or know about. And they would be rubber hammers, actually steel hammers, 2x4s, pry bars. And sometimes the guys will make up their own little, they're usually made out of a nut, and it's called a kick plate. You put it into the door, slam the door, and it cocks the door up to where you need it or want it to be. These kinds of things don't happen with carbon fiber. And the way we found that out was with the very first BMW i3 that came out, where everything was absolutely perfect. No matter which car we looked at, it was within tenths of a, well, I was going to say tenths of a thou, but tenths of a millimeter. These things are dead accurate. And so that's going to, I think, give you a huge advantage as you move forward. So can you tell us a little bit about what testing and validation you've done? Why don't you give us a little background on that?
Sure. The reason the vehicle has three wheels is to be the most efficient. There's a book called The Leading Edge, which I read back in 2004 or so. It's written by a student at the time at MIT, Goro Tamai. He was on the MIT solar team. It's a great book, but he goes into the different aerodynamic shapes and wheel forms these vehicles have. And we felt that this three-wheel architecture gives us both the best stability, but also the least amount of drag and rolling resistance. So that's why the vehicle has three wheels. Technically, the vehicle qualifies as a motorcycle. So we're a registered motorcycle manufacturer in California. And so we're in this weird world where we have to abide by all of the motorcycle regulations. For example, FMVSS. We had two headlights on the first vehicles, like a typical car. But to fill the motorcycle regulations, we had to move to a single headlight at a specific height above the ground and specific size, maybe even less optimum than the two headlight that we had from the car. But that's what we have to do to fit the regulation. We also roll in as much of the automotive FMVSS, roof crush, door crush, front impact. All of those kinds of standards we've designed to as well. So the vehicle has airbags. It's going to be crash tested with the airbag manufacturer next year to calibrate the airbags and the firing computer. But it's designed to all of those same automotive standards, most of them that are applicable anyway. So it's really the best of both worlds.
Cool. Why do you think that your company is coming up with all these new ideas and whatnot? And yet, and I know for a fact that you've talked to other people who said the same thing. Oh, that'll never work. So what did you guys experience?
Well, in our case, I would say it's two answers. We are a very flat organization, so everyone has access to anyone. I have we call my ceremonial office upstairs with Chris, but I actually sit down with the electrical engineers on the floor. I'm not adjudicating problems or solving things, but I keep my ear in the ground and hear, if I know if these 6 people are gathered together around something, I should go look at that thing. And then it just keeps me and the executive team, up to date with what's happening. So I'd say number one, organization is flat. Everyone has access to the top. Everyone can walk into my office anytime, or Chris's office, or Blake's, or whoever. But number two, I think with any big company, you have people who are there, climbing the career ladder 10, 15 years to get to that VP, senior VP level. They're not going to stick their neck out for anything, right? They're thinking about their retirement. They're thinking about their summer home. They don't want to put anything like that at risk. And so I think that's also organizational. It's organizational psychology. The bigger the organization, the less you want to seem like you're failing in front of the group. So no one's going to stick their neck out for something different.
Well, psychology. I have a rule. For everything I've ever looked at, and I've looked at pretty much anything from Barbie to the space station. And that's not a metaphor, that's for real. And I've found that it's 10% technology, 90% psychology. And I think that the reason that you guys can succeed and everybody else doesn't is because of the, that'll never work, we tried it, blah, blah, blah. That's scotoma, and that's what our biggest problem here in North America is. We have strongly held rules and regulations that we can't break unless you do something radically different. And basically we've got 2 radically different companies here. So I've got a question for you. We've heard a lot of stuff about, competition from China and whatnot. So who's your competition in China?
No one.
Who's your competition in China? So that's the difference between someone who's worried about the future and someone who's doing something about the future. So let me ask you the question then, Steve. Who would you work with if you were, let me rephrase that. Has anybody come to you to say, hey, let's be friends?
Yes, I think maybe since we last talked, we had a phone call with an OEM about integration of our not only panel technology, but the high voltage electronics into their vehicle. So maybe offline we can talk more about that. But there is that demonstrated interest, which we're very excited about. And then there's other applications and other industries that we're working to push our solar into, because we believe there's lots of journeys to be powered by the sun that's out there, and we're going to do our best to make that happen.
Okay, so one of them that I know for sure, because some very clever guy on X figured it out, and now that it's in the open, I'm pretty sure you can talk about it. Why don't you tell us a little bit about your products on ground equipment for airports?
Well, most people know every airport around the world, not just North America, there's a fleet of equipment called GSE, ground support equipment. And there's a push globally to move them from gas and diesel to electric. And there's lots of reasons for that. Carbon is one, operating cost is another, maintenance cost is another. But there's a lot of challenges in doing that. Of course, the cost of the new equipment, have to abandon the old, buy new equipment. The cultural, changing the culture of having to plug in the vehicle, even though workers, plug in their cell phone every minute they get an opportunity, they are not trained to plug in the vehicle, so sometimes they forget to. And then, of course, the infrastructure. You can't just install thousands of chargers willy-nilly at an airport. There's only certain areas where the vehicles can go, and you can't block off certain places, and there's a supply chain limit with the high-power chargers. So there's all these things that we thought that were kind of conspiring against the electrification of that industry. And we said, well, what if we could take some particular applications of GSE and make those totally energy neutral, where our technology would completely power the needs of the vehicle. And if you think about it, the airport is a perfect place because there's no trees. Basically, it's full sun all the time if it's not cloudy. There's a lot of places where it is cloudy, rainy a lot of the year. Maybe that won't be the best fit for our technology. We're working on some data and location to see if that's the case or not. But there's certainly lots of places where it is. And so we deployed one of those at Salt Lake Airport. There's a pushback tractor there that's working for a particular airline, where every time that tractor pushes that plane back to the ramp to taxi and take off, it's powered completely by the sun. They don't have to plug that thing in at all. So that's just one piece of equipment, one example, one airline, but you multiply it across all the different pieces of equipment, different airlines around the world. It's a massive opportunity for us. And it's a massive opportunity, I think, for the environment, too, because if you can go from running, dirty diesel engines and gasoline engines on these old unregulated equipment to modern electric that doesn't even have to be plugged in, it basically charges itself, I think that's a win.
So, same question to you. What do you think, Steve?
Well, first, I just want to talk about your example of horse poop. I think it's a great analogy of how a lot of the industry doesn't understand the nature of the opportunity with EVs. So the equivalent of modern EVs from virtually every OEM making gasoline engine sounds is like having a pooping device on your car to make it poop to recreate the horse experience, right? Makes absolutely no sense. Why would you do that? Why would you go backwards? So I think for me and most everybody in our company, we don't need those kinds of things. Virtually everybody there drives electric vehicles because we love them. They're fast, they're efficient, they accelerate past everybody else effortlessly. They require zero maintenance. I have 3 of them in my family. And it is the future, whether or not in other places it adopts as fast or quickly. I definitely believe it's the future.
Is there any kind of wrap-up thought?
They say California leads the nation in terms of how it adopts new technologies and deploys these technologies. I think you're going to see that continue to be reflected. Electric vehicle sales in California and the country have completely outstripped virtually every financial prediction, from Jefferies or Chase Bank or these other banks that they produce McKinsey studies saying, here's the ramp of electric vehicles, and we've blown past that. Mm-hmm. And that's because people recognize just what a superior experience it is. But you can't increase it by beating people over the head with it. You just have to let them drive and experience it, and they see for themselves, and it sells itself.
And that's what I've been basically saying. If we want to see electrification, you're going to have to see people in electric cars, taking them on for a day or two, just to see how much better it is. And quite frankly, I said this in the last session that I was in, talking to some guys at Volkswagen in Germany, and what did they come back with? They said that if we can get a German inside of an electric vehicle, then the product is sold. Period. So with that, we're done. So anyways, thank you all for thank you first, Daniel and Stephen. Thank you for being with us, and thank you for paying attention.